Topic 26, Electromagnetic Induction, Part 2, Transformers. This is a transformer. It has an iron core in the shape of a closed loop with a coil here called primary coil. This is for power input. And then there's another coil called secondary coil, and that's for power output. It says here the magnetic field from the primary coil here threads through the iron core, these dotted lines, through the iron core into the secondary coil. So these field lines thread from this coil into this coil. This has the same effect as moving a magnet into the secondary coil. Here is a more pictorial representation of a transformer. How a transformer works. When an alternating current, or AC, is flowing in the primary coil, it causes a changing magnetic field in the iron core, which cuts across the secondary coil. This induces an alternating current in the secondary coil. A transformer is a device that is used to change one alternating voltage level to another. Here is another diagram of a transformer. Notice this word laminated means thin sheets glued together. And this is the alternating input voltage. That's the alternating output voltage. In this diagram, V1 is the primary voltage, V2 is the secondary voltage, N1 is the number of turns of the primary coil, N2 is the number of turns of the secondary coil. This is a very important transformer equation or formula. It says the primary voltage over the secondary voltage is equal to primary turns over secondary turns. Here is the question, and here is the answer in detail. Just read through it carefully yourself. Question 2 asks for primary turns. It says the number of turns required for the primary coil. You can just read through this carefully yourself. For an ideal transformer with 100% efficiency, power input is equal to power output. In other words, there's no power lost. And from here comes this formula. Input of primary power equal to secondary or output power. Memorize that. This question requires the application of this formula, and you can just look through it yourself. Here is another question that requires the application of this formula. Just look through the answer yourself carefully. There are two types of transformers: step-up transformers and step-down transformers. In a step-up transformer, the secondary voltage is greater than the primary voltage, and the secondary turns must be greater than the primary turns. Practical application of step-up transformers. To increase the voltage output from a power station from 25,000 volts to up to 400,000 volts. In a step-down transformer, the secondary voltage is smaller than the primary voltage. The secondary turns must be smaller than the primary turns. Practical application of step-down transformers. To decrease the voltage output from the main supply from 240 volts to 18 volts to power and recharge a laptop computer.